So now we're going to focus on the cardiac cycle, right? So cardiac cycle is basically the amount of blood that travels throughout the heart in one beat, right? So there's an actual specific process that takes place. So first, around 65 millimeters, that's how much is the minimum amount of volume that's usually in the blood. If you don't have this much blood, you're probably leading to some kind of heart failure, some kind of pulmonary problem. So it's really important to have about 65 milliliters of blood. We call this point A, right? So if you can notice from this graph, first of all, I am showing you a comparison of pressure versus volume, right? And so if you remember a little bit from chemistry, right, you remember that V, which is volume, is inversely proportional to pressure. What does that mean, inversely? So as pressure increases, what happens to volume? As pressure increases, volume goes down, right? And you're gonna see this correlation here during the cardiac cycle. So from A to B, the first phase here, to about 135 mils of blood, this is referred to as ventricular filling, right? So A to B, we can abbreviate this as ventricular filling, right? So the ventricle is relaxed and all the blood is being poured through this chamber, specifically the left ventricle. So, right, so all of the cardiac cycle is relative to the left ventricle, right? Because it's the bigger one. It's the one that goes to what volume, what system, the pulmonary or the systemic. It goes to the systemic circuit. So systemic circuit is the rest of the body, right? So from A to B, what do you notice on the graph? You notice that the pressure remains the same. However, the volume increases, right? So it goes from 65 milliliters to about 135, right? So then there's a tendency of an instance of a contraction here where the pressure changes from B to C. So from B to C, you notice that the volume remains the same, right? The volume doesn't change, but the pressure increases. This is called isovolemic contraction. So during this time, the heart muscle contracts readily, however, it does not lose any volume of blood. The next phase here, from C to D, you'll notice that there is an increase of pressure, but also a decrease of volume. From C to D, this phase is known as ventricular contraction or ejection. So during this time, heart muscle is contracting very deeply and it's causing the pressure buildup in the heart to increase, right? Which forces most of the blood to leave the left ventricle, right? And this is coined ventricular contraction. And the final phase of the cardiac cycle, right, going from C to D here, and then D to A, finally, right back. This is where you don't have a change of volume, so the volume remains at 65, okay, 65 milliliters. However, you notice that what? The pressure decreases. So this is known as isovolemic contraction, or relaxation, excuse me. Okay, and this is just a basic understanding of the cardiac cycle, right? So there's 2 points that are important on this graph. This is one is the end systolic volume here, coined at D. So I'll put a little quote here. And then you have end diastolic volume here at B, right? So end systolic volume takes place where the amount of volume, right? So what did we say systole was? Systole was contraction, ventricular contraction. So it's the highest pressure. Highest pressure usually indicates what in terms of volume? It indicates lowest volume. When we look at diastole, what do we notice about diastole? Diastole is ventricular relaxation. So this is the lowest pressure. So what do you notice about the volume? The end diastolic volume usually is the highest.